So we've taken a look at the notes for lesson 1-1, and you've taken, hopefully, a few minutes to look at each of those problems. Now I will go through each one of those individually. First, let's take a look at this figure. Let's identify all the things that we see. We have point J, K, L, and M, just the 4 points. The next thing we notice is a line. There are a few ways we can name this line, starting with line A. We could also use the point on the line to name it. JK, you must remember to use the correct notation, the line with the 2 arrows. Again, KJ. Also, LJ or JL. And then lastly, KL and LK. Those are the different ways you can name this line. When talking about collinear and non-collinear lines, we can see that because J, K, and L are all on line A, on the same line, that they are collinear. The only one that is not collinear in this figure is line M. Now we can talk about the plane that we see that encompasses all of these figures. We can use that script letter B to name this plane, or again, 3 non-collinear points. So I could use J, K, and M, or M, K, L, or J, L, M. Again, it doesn't matter which 3 non-collinear points you use. Okay, so we're going to take a look at these first problem that we have here. And it says, use a figure to name a line containing point K. As we see, like we just talked about, point K is on line A. Again, we can name that line just by saying line A, or writing JK or LJ. Any 3 of these answers would be acceptable. Now, use the figure to name a plane containing point L. Again, any of those that we mentioned a few seconds ago, we can say plane B, or use any 3 non-collinear points. I'm going to use M, K, J. Okay? Any one of those 2 answers would be acceptable. We can now take a look at some real-world examples. Let's name the geometric shape modeled by a 10 by 12 patio. That would be a plane. Or if you were to look at a button on a table, that button would be a point, but if you looked at the table, that would also be a plane. A colored dot on a map used to mark the location of a city. Again, that map could be an actual plane, but the dot would definitely be a point. And if you looked up at the ceiling of your classroom or of the room that you're in right now, that would also be a plane.
If you notice, we haven't yet talked about a line in these examples. Why is that? Well, by definition, if you remember, a line moves infinitely in both directions. And if you look at the space around you, you really can't find anything that resembles a line that would move in both directions infinitely. Everything has a beginning and an end. Now let's draw and label for the following situation. Plane R contains lines AB and DE, which intersect at point P. Then add point C on plane R, so that it is not collinear with AB or DE. So let's start with plane R. I'm going to draw this really big, just like a tilted piece of paper. Okay, we're going to name it R. Let's a little cursive R in the corner there. Now we need lines AB and DE. So I'm going to draw a line there Make sure you draw the arrows at the end. Draw another line here with the arrows. Now this first line, we're going to name it A, and then B, doesn't matter where the points are. This one was D, and E, intersecting at point P. Next, add point C on plane R so that it is not collinear with AB or DE. That means I could just randomly put it anywhere on this plane. It has to be on the plane C. Now it doesn't have to look like the way I drew it. Here's another example. If you don't like my drawing, I can give you that figure there. Again, has plane R with lines AB and DE, which intersect at point P. You added point C there, so it's not collinear with the other two. We're going to draw and label for the following situation. Line QR is on a coordinate plane that contains both points Q and R. We're going to add point T so that it is collinear with these points. We're going to start with point Q at -2, +4. Draw this guy in here and label it Q. We're then going to draw 4 at 4, -4, and make sure you label it. Then going to draw a line that passes through both of these points. Make sure you put your arrows. Lastly, add point T so that it is collinear. Remember, collinear means that it's on the same line, so it doesn't matter where on this line you put the point. I'm just going to place it right here and make sure that it is labeled. Now here we have a multiple choice problem. We're going to choose the best diagram for the given relationship. It says that plane D contains line A, line M, and line T. All three of these lines intersect at point Z. Point F is on plane D, and it is not collinear with any of the given lines. Okay, the best answer for this relationship is answer B. It's got all three of the lines T, A, and M. They intersect at point Z. Point F is on plane D, but it is not collinear. If we look at the other three, in answer A, point F is on line A, so that wouldn't work. On answer C, line A goes through plane D. It's not on the plane, it goes through it. And in figure D here, Z is not the intersection point. F is the intersection point, so that wouldn't work. The next question is, how many planes appear in this figure? The answer is 2, and let me explain. Most of you probably wrote that you saw plane S, okay, which is right. That is one of the planes. Now, if you looked at the two lines, AC and AB, they are not on the plane. They go through it. Both of those lines actually form a different plane. And we're going to call that one just plane ABC. It would be kind of hard to visualize at this point, but there are two planes that intersect at line BC. Now it's asking us to name 3 points that are collinear. The correct answer would be points A, B, and D. They are all on the same line. There are other points that are collinear to each other, but there are only 3 points that are collinear. Next, at what points do lines DB and CA intersect? Line DB, which is this one here, and CA, which is that one there, intersect at point A. How many planes appear in this figure? Again, this may be difficult for you to visualize now, but there are actually 2 planes in this figure. The first one is the blue one that you see there, and we're going to call that plane T. The other one is the one that intersects plane T at line XOR. That one, we're going to use some other letters, plane A, B, we're going to use N. This one says name 3 points that are collinear. There are a few answers you can give for this one. A, X, and Z is one combination. We can use B, R, and N. Those 3 points are collinear. And finally, X, O, R. Each of these would answer that question. This one asks, are points X, O, and R coplanar? The answer to this question is yes. They all appear and lie on plane T. The very last question asks, at what point do lines BN and XO intersect? To answer this question, let's first identify line BN and XO. It is very clear now to see that lines BN and XO intersect at point R. So the answer to this question would be point R. Again, that's the end of the problems for this packet for lesson 1-1. If you have any questions, please do not be afraid to ask when you come to class.